Welcome to another RDWorks Learning Lab. Another day, another cup of coffee, and today, as I promised you, we're going to jump off the cliff. And we're going to see whether this baby flies. Last time was a bit boring, going through the design process, watching all that CAD stuff, watching all that assembly stuff. Today, well, my hair is great to start with, but there may be not much of it by the time we're finished. Depends how things go. So let's dive in and make a serious start at ripping the machine apart and going for the ultimate beam alignment system. Well, here we are, it's crunch time. We're going to start disassembling things. Now, before you start, what I would advise you to do is to guess approximately where the center line of your mirror is as it stands at the moment. And I've put a black dot on there where I think the face of my mirror is. Because what I'm going to do is approximately, and it isn't too critical, we only need to be within a mil or two. I'm going to measure from the edge of the machine here, just a reference point of some sort. Doesn't matter whether it's true or not, but it's a fixed point and it's approximately 73 millimeters in from the edge. That's where the center of my mirror is. So we'll just make a note of that. 73 millimeters. Because that will be approximately the alignment of mirror number 2. Well, I've also undone my clamps here, which allows me to open up like that. So let's just push some tube back up through there. We can take the cathode wire off and hopefully I can lift that tube up, take my clamps out. Now hopefully I shan't need any spacers anymore. I'll take that clamp out. See, that's what the sticky stuff was just there. Okay, the last time I do this with a bit of luck. Get rid of these horrible fixings and mirror arrangement. One of the other reasons for choosing the different sort of mirror type was so that I don't have to go through this rigmarole every time I want to access my mirror. I should be able to roll the tube in there, I think. Like that. And slide this. Forgot about that. So I've got to roll it in from the back, not the front. There we go. Like that. And rotate it round. Put the clamps down a bit. Pull those cables out and wow. Now you can see the purpose of these tongues here now. These tongues that stick out the front are locating on this front lip here. And the idea is that when we need to adjust the tube, we can adjust the tube backwards and forwards only by a small amount. Something stopping at that end, but I don't think that matters. I don't think we're in trouble. You can see there's a couple of bolts just here which hold this top plate on, which just might stop me moving the mirror far enough that way. Let's have a look. We're looking to have, if I remember rightly, about 73 millimeters to the center of the mirror. It's probably somewhere about there. and I've got 5 or 6 millimeters clearance there, so I should be okay. Now right in the middle here I've got a fitting. It's my light fitting, and it's stopping me from pulling it back this way. So the question now is, can I rotate that up enough? And that should enable me to just get in there with my Dremel and take that piece of material away. There we go, that's all it requires. We've got a little problem. It's only a very small problem, but it's a little problem. There we go, that should be easy. That should be plenty. Well, that's good, because now this slides backwards and forwards 15, 20 millimeters, which will be absolutely buckets. Now, just to be safe, I'll stick a piece of tape over there just so I don't get anything in that window, because I'm now going to do a bit of hole stretching. Okay, now the other end is going to be more difficult, because I've got to somehow lift this tube well clear. Well, we're taking the old mirror, the copper mirror, and look, after several months, I don't know what it is, 2 or 3 months of use, it's not oxidized, it's as good as new. I'm very impressed with that. Pop that into there, and I'll put an O-ring in behind it just to keep it in and keep the load on it fairly even. Now I've got a special temporary screwdriver here made out of Macrolon. And we will shine our beam into the hole. Yeah, although you can't, yeah, you can just see that that's slightly off to the left. So basically what we've got to do, we've got to replicate that position now at the front. So I'll just put my finger over the beam so that we can see the beam is actually dead center, and that's not what it should be. It should be slightly to the left. So we need to tweak it very slightly to bring it to the left, like that. Now when we bring it to the back, just slightly to the left, you see, spot on centre and slightly to the left. So now that axis is set up correctly, and would you believe it, my mirror is in the right place first time. Technically, I suppose I could go across about a 1/16 of an inch. And so let's do that, shall we? Let's just, now, all we've got to do to get that beam on centre left to right, we've got to move it slightly to the right by about 1 millimetre maybe. So I'll just loosen the 2 fixing screws off, one here and one at the other end. And looking at our target, all I've got to do is physically just move the head across, move this mirror 1 across, so that it's spot on centre. Job done. We can tweak that. Now this is step 1. This is just sighting. So why is that not going down? I'm not adjusting it sideways. I'm adjusting it up and down. Well, that isn't what it says on here. As I push it across more and more, it goes up. Now I want to push it down and it goes across. So what is going on? I definitely want rid of this mirror. Right, that's it. You're now seeing frustration in action. I've been fed up with that thing for 2 years. I've done all sorts of mods to it to try and make it better. And now it's coming off. I'm going to replace it with this much more elegant and sensible mechanism that I know works. The only problem is it's too tall. So I have taken a few basic dimensions for reference before I strip this off, by the way, so don't get too worried. So we'll take out the screw that I put in to stiffen the bracket up. That's a pretty... Let me be careful with my words. I found an odd piece of aluminium section which is not going to fall over in the wind, as you can see. It's probably 6mm thick, 1/4 inch I suspect, because this will be imperial sizes, and it just so happens to be the same size as the bracket that I'm taking off, except it's a little bit longer, which is great because it means I can extend it out here onto this very strong section which is bracketed off the bearings and the top of the rail. So it's a really nice stiff section just there for me to drill and tap through. But what I've done initially is just put a couple of tapped holes in here, because what I'm going to do is to use these original fixing points to mount this onto this bracket here, which is a pretty flimsy bracket considering it's taking this cable tray, which doesn't take a lot of load, but in fact even that load was originally flexing this bracket and causing the beam to wobble around, and that's why I had to put this screw in here to fix it to this solid fixing point, and that got rid of that problem very early on. Yep, that'll go. And now what I've got to do is set that level with this. Well, I would say that looks pretty good. Looks pretty level. And there we go. You see, look, I've got myself basically a height reference here that I can nominally use to set this distance here, which is good. And it's remarkably good that it's two pieces of this material, which I think is more or less 12mm. I will check how true this is to that. Not very looking from the top here. I would say it's running out quite a long way. Well, my bracket might look a bit of a bodge. This bracket in the background here is badly bent that way. It's not straight along this edge, it's all sort of buckled and bent. And what I've basically done is I've put some shim washers behind there to pack this out so that that piece of angle is now dead square to that rail. And that means I can now use that back face there as a reference to set my mirror off at 45 degrees and allow it to float this way In fact, thinking about it, in fact we only want, well, we almost want this one fixed. The only reason I need it adjustable is so I can get it into a nominal position to start with, and then any other adjustments will take place on the head. As you can see, I've slightly tidied this bracket up. I've painted it so that it's more of a match for the machine. It's black and it doesn't immediately drag your eye towards it. You saw that I needed 2 pieces of 6mm acrylic to pack the mirror up to the right height. Well, to be honest, I've got to hold my hands up and say I'm guilty of something I warned you mustn't do, and that is rip the machine to pieces before you prepare. Well, you saw my frustration at that stupid mirror 2. It's been bugging me for best part of 2 years now, and it's gone. And off camera, I cheated and I used my other machine to quickly knock up a mirror mount. So now I've got a nice mirror mount. Let's just take this apart and show you what I've done. Basically what I've done, I've designed a plate with a couple of guides on it, and those guides hold the mirror at 45 degrees, and they allow me to adjust the mirror by about plus or minus 2 or 3 millimeters. Now, I don't need that much movement, but because I'm designing this in fresh air almost, I don't really know what I'm doing. I've only got it approximately. I thought, well, I'd make some adjustment so that I can make sure that in this direction I can line it up approximately with my head. So this is only basically a once-off adjustment. Once I've got this mirror set, I will do all my adjustments on the tube and the head. This will become, if you like, a reference mirror. So the first thing I'm going to do is to bolt this plate down solidly onto this base plate. And hopefully this should be a pretty secure, solid mount now. Yeah, there's not much movement in there, is there? That's 10 times less, let me use a technical term, wingy-wangy than the previous flimsy bracket was. Okay, so now I can drop that in there. I have to say, when I retired, I never thought I'd be doing metal engineering with bits of acrylic. Just have to make things a bit thicker, that's all. But it's a great material for this sort of job. That's what I think is probably a nominal position. And we'll see how we have to adjust it. But as I've already found out, you can't trust the red LED pointer to be exactly the same as the laser beam. So we're still going to have to use the time-favoured pulse burn method. So let's just set it up approximately. Now the first thing I need to do, I think, is to move the tube across. So looking from the back here, I can pick up the tube and I can slide it across like that. Now that's not saying that that is the correct position, but what I'm demonstrating is how easy it is to adjust the beam. So it's just a matter of loosening 2 screws at the back, and I can set that beam completely onto the centre of that mirror. And we'll see how we're fixed on. Well, we're here at the moment. So now it's a matter of, oh, I can do that from here. We want it up, and then we want it across. And now we want it down. Now, isn't that easy? With that mirror arrangement, no faffing around. Now, that might not be right, but the point I'm demonstrating is how easy that mirror adjustment is. It's solid. Okay, let's remove the red dot pointer now. Stick our target on the mirror, like that. Now sadly you can't see that target from there. So there we go, you're at the front of the machine now and you're looking towards mirror 1 from the front of the machine. And there we go. Now despite my best efforts to line that mirror up on the centre of the tube, it hasn't happened. That mirror needs to shift over by 4 or 5 millimeters. When I designed that I did say, should I make that adjustable? No, let's be confident. But I just can't imagine how I could get that 3 millimeters out of line. Okay, let's go and see what we've done to mirror 1. Now that I've adjusted it, made it adjustable, and I've reset the mirror across about 4 millimeters. Well, I think we could say that that is a pretty good success right in the centre of the crosshairs. So I've got a little bit of smoke in the middle of mirror 1. I'll just clean that up with some isopropyl alcohol, and then it always leaves a film on there, so I should just give it a gentle wipe with a piece of tissue. Okay, so that's mirror 1. Well, it's not actually set up because I haven't locked it up yet, so I better put the screws back in, because we shall then need to adjust this backwards and forwards in a minute. There we are, right at the front of the machine, furthest away from mirror 1. Low. More or less on centre. So that's what I call a sighting. So we've got our mirror set up approximately right for the end of the stroke there. So that's always step number 1. So step number 2 is always to bring the mirror in close to mirror number 1. Okay, and now what we're going to do is what I call produce a target burn. Okay, now it's way offline, but don't let that worry you, because that's what we're trying to match at the front of the stroke. Okay, so now we'll take a look where we are at the front of the stroke, and we should be roughly in the middle, which we are. So now what we need to do is to steer the beam to the left. I think we're nearly there, look. Just a tweak back. And I think we've done it. Just like that. Now, what that's done, that's now put the beam parallel, both in the horizontal and the vertical plane. And what I'm now going to do is to adjust the tube. I'm going to physically move using these reference pegs, which are pulled against the front here. Without changing anything, I should be able to slide this tube across. And as I slide it across, I should be moving the beam on the target. So let's do another test burn. And bingo! We're right in the centre of the target, just like that. So that means it's taken me what? 1.5 minutes, 2 minutes to set up the y-axis. Fine. Just 2 screws and the job is done. It would be easier if I could get to it from the top here. But hey, I'm not complaining at the moment. That was dead simple. So using our other target, the first move is to put the head as far away as possible. and we do just a pulse. Well, here it is, right down here. Right, so that's stage one. We've got our sighting beam roughly in the middle of the target. It's not important, it's just a sighting, just to get the beam into the right sort of ballpark. Okay, now we start the alignment process, which we do with a target burn. So we'll move the head close to to mirror 2, and we do a test burn. So this is the target burn. Right, so it's a long way out. Now remember, this is the first time that I've used this mirror, and I'm not sure that it's in the right position. So that's one of the reasons why I've built this little bit of adjustment in here, so that this time round I can move the mirror and the beam across by, what, 4 millimeters? Something like that. Just do another pulse, and there we go. Look, you see, I've shifted the beam right across to where it nearly needs to be. And we'll just lock that up, and that basically is the correct position now for mirror 2. Okay, now that I've locked that mirror up into this nominal central position, any other adjustment that I'm going to make is going to be made on the head here itself. Well, let's get it set up parallel to start with. So what I've just produced there is a target burn. So that's the one that we're trying to match. So I've got to come down, which is good. Up, 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 up. There we go. And now we've got to come across. Not bad. Now we just got to come up a bit. Well, that looks pretty good. Easy to do with that mirror setup. That's very easy to do. We'll just check it again, just to be sure. Target pulse. Too high. Now, as we're only interested in marks, not the actual target, we can turn that over. Do the same thing again. And there we go. So basically we've got our mark here, and we really need it up here. That's a long way out of position. So here comes the great advantage of having the head movable now, because all we've got to do is we've got to drop that spot up. Now I know that sounds right, we've got to drop the head to catch the spot. 7 or 8 mil. We'll just do another quick test, see where we are. Well, you can't get much better than that, can you? Except the fact that we're very slightly off centre. So I've got to move it this way, just a little bit, I believe. Let's look. Yeah, it's about 1 millimetre off centre. So we've got to move the head out very slightly by about 1 millimetre. Right, well, before we do anything else, I've just adjusted it up and across, and we'll just check the squareness in both planes. Okay. Now I'll just snug those screws up so that they don't move. Just tighten a couple of them up and then we'll check it again. So I've still got to go. In fact, I've overdone it slightly. Well, I think that'll do. So I just tighten the screws up now. So that's square in that direction. Sorry, that's how simple it is now to get the x-axis sorted out. Now the next thing we're going to do is tackle the z-axis, which is basically the lens tube. Now the problem that you've got with the lens tube is there is only literally one position for that beam to fire down that tube, and that's right down the centre of the tube in line with the axis of the tube, so that it hits the lens square and in the centre. You'll either lose energy or get reflections off the inside of this tube if you're not lined up. So there is only one position that I call a sweet spot on this mirror. Now on my machine here, the sweet spot was probably something like about 4 or 5 millimeters above the centre of the port that comes into the machine. So if I'd have been firing at the centre of that port, I would have been reflecting the beam down there. So I would have then steered that to get it onto the centre of the lens, and in doing so my beam would have probably then been veering off like that. So to get a vertical beam down there is quite essential. But it's not only got to be vertical, it's got to be in the centre of the tube. I found out about the error in this when I couldn't get consistent power. I was getting far too many losses here on this lens or at this mirror. It was a combination. I was losing power here, and so I had to investigate, and that was when I found out about this sweet spot and the fact that this head is totally incorrect as far as its design is concerned. The actual beam doesn't even hit the centre of the mirror, but it's sufficiently close to centre that it isn't a major problem. The biggest problem was that aiming at the centre of this port was actually putting me in totally the wrong position. So that's another reason why you've seen me being quite careful about getting this whole head assembly at 90 degrees to the table. So I've taken the nozzle off my tube there, and what I've got is a little holder here, which, very simple, a little two-piece holder that takes my little mirror targets, and the mirror targets sit in the bottom there, and I can then raise the table. Well, there we are, all nicely lined up. And now we've got to adopt the same procedure with this axis as we did with the X and the Y. The first thing we've got to do is to drop the head down a reasonable distance away, say 6 inches or so. And now we're going to do a burn. And yeah, it's no major problem. It's within a workable area. It's pretty close to centre, but it's within a workable area. And now what we're going to do is we come back up and we'll put a clean target in, or at least we can turn that one over because it doesn't burn right the way through. Sit it down nice and square on the table. Now we're going to drop it down just a small amount, maybe 3/4 of an inch, something like that. Okay, now what we're going to do is the target burn. So we've done our sighting burn, now we're going to do the target burn. And it's looking pretty good for centre. Now we're going to drop it down. Okay, now we'll do the same thing again. If anything, it's come very slightly this way, so we need to steer the beam very slightly backwards. So we just twist it in a shade. Just a shade too much, and then we'll twist it. Very sensitive, this axis. There we go. And I would say that that is now a match. So we can see from that test that the beam is more or less coming right down the centre of this axis, and it's also now running parallel in this axis. So we've satisfied exactly the same conditions as we did with the other two axes. We've got it true in this axis and that axis, and it's going straight down. So when we put the lens on now, this is a 2-inch lens in here at the moment, I think. So finally what I'm going to do is just check that the beam is going basically vertically downwards as well. So we'll just set this up for its correct. This is a 2-inch lens, and I think it needs to be at about 18.5, which is there. So that gives me a nice clean little spot. Now we'll drop this around about 1/2 or 3/4 of an inch, because to be honest, that's sensibly all you're going to be using this lens for, 1/2 an inch at the most. About there. We'll just see how this now sits on top of that dot. Well, I think you'll see that it's pretty well spot on. So I'm very happy with the setting of this machine now. And as you can see, it really didn't take that long. This is a prototype setup, and so it's taken me a little bit of fiddle time, but subsequently this is going to be a breeze. Everything's adjustable, everything's nice and easy to set. We've got the tools for doing the job. This little device, these little targets that just fit into the front of the mirror. Everything designed for simplicity. Well, after a little bit of frustration with my mirror number 2, I feel very happy now that I've got something here which is reliable and very easy to set. I should have done this 18 months ago, but hey, there have been other things more important. If it ain't broken, don't fix it. Well, it was ready to break the first time I did touch it, and so there we go, I fixed it. That was not part of the plan, not intentionally part of the plan, but I'm glad that it's worked out like this, because now I've got a very easy machine to set up and maintain.